In this video, I'm going to show you a two-step process to find the eigenvalues and the eigenvectors of a 2x2 matrix. So step number one is you take the matrix that's given to you and you write it out as A. Now in this question it's already done for you, but in case it isn't, I would honestly just do it. Now lambda I is lambda multiplied by the identity matrix. Now here we're going to use a 2x2 identity matrix because we're dealing with 2x2 matrices. So that's 1 along the diagonals and then 0 everywhere else. Now, whenever you multiply a matrix by a scalar, you just multiply each individual part of the matrix by that scalar. So lambda times 1 is lambda, 0 times lambda is 0, so on and so forth, and then lambda times 1 again is lambda. Now, a minus lambda I, this video, okay, I'll explain this afterwards, but it's going through a 3x3 matrix actually. Now, a minus lambda I is what you get when you take the matrix A, that's given to you in the question, and you subtract it from it, lambda I, so lambda 0, 0, lambda. So you subtract from it lambda I. When you do that, 2 take away lambda is 2 minus lambda. 1 take away 0, supposed to be 0, is 1. 4 take away 0 is 4. And 5 take away lambda is 5 minus lambda. Now that we've got the expression for a minus lambda I, we find the determinant of it and make it equal to 0. The determinant of any 2x2 matrix, what you do to get that is you do 2 minus lambda times 5 minus lambda. So essentially you do the multiplication of these two values, take away the multiplication of these two values. So let's do that here. 2 minus lambda multiplied by 5 minus lambda, take away the multiplication of 4 and 1, which is 4. 2 times 5 is 10, 2 times minus lambda is minus 2 lambda, minus lambda times 5 is minus 5 lambda, and minus lambda times minus lambda is plus lambda squared. All take away 4. Now the lambda squared is already positive. The minus 2 lambda take away 5 lambda is minus 7 lambda, and 10 take away 4 is plus 6. When you make that equal to 0, you get the two eigenvalues for this question. Now, from there, it's pretty much solving like a quadratic, which I'm sure you guys know how to do. And once you've done that and you've solved, you get that lambda is equal to 1 or lambda is equal to 6. Now, the format that you like to use for eigenvalues is lambda 1 for one eigenvalue and lambda 2 for the other eigenvalue. Now that we've got the eigenvalues, we can find the eigenvectors using step number 2. To do that, we take the expression that we formed for a minus lambda I, which is this expression here. You replace it with these individual eigenvalues. So let's do that first. For example, for the first eigenvalue that we found of lambda equals positive 1, I'm just going to erase some of this here actually. It's unnecessary. But yeah, for that first eigenvalue, lambda 1 equals positive 1. A minus lambda I becomes, well, 2 take away 1 is 1. 1 just stays as itself. 4 just stays as itself, and then 5 take away the lambda value of 1 is just 4. All multiplied by xy. Again, because we're dealing with 2x2 matrices, we multiply by just xy. And that equals 0, 0. That allows you to form two expressions. First of all, 1 times x is x, plus 1 times y is y, and that's equal to 0. If you form the other expression, you'll see that 4x plus 4y equals 0, but that gets you the same solutions as this one, so we don't really need to include it. The importance of this is it tells you that if x is equal to 1, y would have to be equal to minus 1 in order for x plus y to equal 0. And that tells you that for this specific eigenvalue, this is the specific eigenvector. We now do the same thing, but this time we're going to find the eigenvector for this specific eigenvalue of positive 6. So for the eigenvalue of positive 6, again we do the same process, so this time replacing lambda with 6. 2 minus 6 is minus 4, this value stays as 1, this value is 4, 5 minus 6 is, it's minus 1. All multiplied by xy is equal to 0, 0. When you're doing this, you apply the same process, so let's do the bottom one this time, because as you can see, it will lead to the same expression. But 4 times x is 4x, minus 1 times y is minus y is equal to 0. Let's now think about what value of x and y would make it so that this expression is true. Well, when x is equal to 1 for this case, y would have to be equal to 4, because 4 times 1 is 4, and 4 take away 4 would get you 0. That means that for this eigenvalue, this is the specific eigenvector. And that's your set of answers for this question. Hopefully everything made sense, and yeah, that's how you find the eigenvalues and eigenvectors of a 2x2 matrix. I'd like you to memorize these two key facts, because that's what you sort of need to remember, and then the rest of it falls into place like a puzzle. Be sure to like the video if it helped and subscribe. Share the video too with all your further maths peers. I'd appreciate a lot. And yeah, I'll see you in the next video. Thanks for watching. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excelineducation.co.uk.